Welcome back, guys. If you have just joined us, we are doing life sciences for grade 12, and today we're working on paper 1 revision. It's already been very nice, and you guys are already enjoying it because it is very relevant and important to what you are dealing with in your lives at this very point in time. So in case there is something that has been bugging you or something that will help you for the future in your exams or was bugging you for the last exam, whatever it may be, and it's related to this that we're doing right now, please don't fear to send us questions because that is exactly what we're here for. Over to you, Aslam.
Thank you, Katlego. Let's move on, guys. Welcome back. I'm hoping you revitalize. We've done a little question on DNA replication, and the differences between DNA and RNA. Now we're moving on to a question on protein synthesis. The question says, the diagram below shows one stage in the synthesis of a protein at a ribosome. One stage in the synthesis of a protein, so we're dealing with protein synthesis at the ribosome. And that is an important clue. And I'm hoping you're watching how I underline the key words as we're going along. That is the most important thing, guys. Most of you know the answers of questions, but you don't know which answer fits where because you do not read properly. And once you get into this habit of underlining the key words, your job, half of it, is already done. You just need to then put those answers together. So they've given us a diagram here. They're showing us there, something's happening there on top there, a transfer RNA. That's another clue in the diagram. Another clue is given is amino acids. When you see the instruction, the little introductory paragraph of sentence and the diagram are giving you clues to the rest of the question. And they're talking about some bond there. They're giving you some nitrogenous bases. They tell you this is messenger RNA there, and so on. They say, name this stage in protein synthesis. What is the name of this stage? And obviously, like I said, the clues were given to you. The fact that they mention ribosome, the fact that they're talking of transfer RNA, the fact that they're talking about amino acids, that all leads you to the answer that this is translation. Remember, when we started, we spoke about two stages in protein synthesis. The one was transcription, and the other one was translation. That's what we're talking about here now. Remember, transcription takes place in the nucleus, and translation takes place in the cytoplasm, more specifically at the ribosome. Just by the way, the word transcription means to make a copy. Transcribing, if your teacher wants to use high terms to you when you are looking at your friend's work, or if he notices that your work and your friend's work are the same when he's marking your assignment, he says, Katlego, why have you transcribed from Jonathan? What does he mean? You've copied. All right? So transcription means you've made a copy. Remember that. So which copy are we talking about? From DNA. And what do we form? Messenger RNA. Those are the most important things you know about transcription, and you need to explain that. We'll worry about that when we deal with the essay question. Transcription and translation, translation. If I start talking to you in Arabic now, or Gujarati, or Urdu, or Swahili, or any other language that you are not familiar with, you would need somebody to translate that to you. So in other words, we're taking something and we are translating it, or we are changing it to a more, or to a different structure in this case here. So we've taken a code that we got from the nucleus, and we're converting that code into something else that we can use, and that is called a protein, and the process is called translation. Name the bond X. Where is the bond X? Not James Bond, the bond X. Maybe we must come out with our own movie, Bond X. But here we're talking about, and what are these things? They gave you a label here. These things, 1, 2, 3, 4, 5, are amino acids, or amino acids, whichever you prefer, as long as you spell it correctly. There's a bond between two amino acids. And that bond, your grade 10 work would have informed you about this, but in grade 12, we touch again on that. That is called, and let's go back there, down, and we say that's a peptide bond. So a peptide bond forms between two amino acids, adjacent amino acids. Two amino acids together, in this case here, would be called a dipeptide. The third one is also there, so this is a tripeptide. 2 amino acids, dipeptide, 3 become tripeptide, and then on we call them polypeptides. What type of bonds are indicated by the dashed lines, and state what characteristic do they have that makes them suitable between the nitrogenous bases? What type of bonds are indicated by the dashed lines, these ones here? And what special characteristic do they have to make them suitable as bonds between nitrogenous bases? And remember when I asked you just now, what are those bonds between two adjacent strands? We said they are hydrogen bonds, and I specifically said we must add the word weak in front of them. Now there's a question that's addressing that. What type of bonds? We say they are hydrogen bonds. And they said, what characteristic do they have that makes them? They are weak bonds. That's the answer to that one. Katlego, we had a question earlier about this.
Yes, we did. Let me get it for you. It's so down the page now.
What
so
would happen
you
if...
something about the strong
The
bonds.
question was, yes, good. The question was, what would happen if the bonds, the hydrogen bond was strong?
Okay, here you go. It's the question by Roxanne.
Yeah.
She asks, what would be the consequence if the hydrogen bond was strong? That's it. You got it right.
Okay. So she wants to know, Roxanne.
Roxanne.
Roxanne wants to know, what would happen if these hydrogen bonds were strong? We said that the weakness makes them suitable to form between the nitrogenous base. Now we need to go back to our first question, which dealt with DNA replication and transcription. And now we're looking at translation, where the transfer RNA molecules combine with the messenger RNA. Look at this transfer RNA here. It has combined and it moves away. So it means that these bonds that form must be able to break easily. If they were strong bonds, then the bond would not break and the strands would not be able to separate. And if the strands could not separate, DNA would not, Katlego, be able to make a copy of itself because it cannot separate. Messenger RNA, once it formed on DNA, would not be able to detach, and therefore it would not leave the nucleus.
Okay.
And therefore it would not get here, where it is here down. And thirdly, guys, the transfer RNA, once it combines with the messenger RNA, would not also be able to detach. So it's stuck there, and consider the transfer RNA as your taxi. If your taxi gets to the spot to drop off passengers, Katlego, and it has a puncture, which is famous excuse I get every single morning. We had a puncture. The taxi broke down every morning. So if he gets stuck there, he can't come back to fetch more passengers. And in this case, the passengers are amino acids. So in other words, if transfer RNA gets stuck here, we cannot get more amino acids, so the process of protein synthesis in all these steps stops. So the ultimate, the end product is that protein synthesis will not take place. But now, I give you this scenario as well. It's all very well to say in this type of a question that Roxette has posted that protein synthesis will not take place. You will get 1 mark for that, because that's the last statement that you have to do that. But if I have a heart attack, I will die. I may survive, but you can give I may die as well. So I'm going to die right at the end. But what has happened between the fact that I got a heart attack till the point I died? Why did I die? So in other words, we need to explain the steps
before
to get
that.
There. Okay? So what are those steps? Replication will not take place. And if replication doesn't take place, then the DNA doesn't split, and therefore it's not exposed to the messenger.
Yes.
Secondly, messenger RNA, if it does perhaps connect with one DNA strand, it cannot separate. So if it doesn't separate, it cannot then go out, and it cannot give the code to transfer RNA. Thirdly, if transfer RNA gets stuck to messenger RNA, it cannot separate, it cannot fetch more amino acids, so the process stops. As simple as that. So in other words, in this question, where they say, that's why I didn't explain this, because I wanted to deal with that question. What characteristic do they have? The characteristic is that they are weak bonds. You would have got the mark here anyway, because they only ask you what characteristic. They have weak bonds, and if they said explain why, so that they can easily break during replication, transcription, translation. In all 3 processes, we need this bond to form and to break easily. I'm hoping we on the same page. Give the messenger RNA codon that would code for the transfer RNA bonded to amino acid number 5. We go back. Amino acid number 5. That's amino acid number 5. It's on this transfer RNA. There's the amino acid here. Here's the transfer RNA under, and the letters given there are GUG. Go back to our question there. So our transfer RNA is GUG. They want to know, if this is a transfer RNA, which part of the messenger RNA would this particular amino acid or this transfer RNA combine with? Obviously, you know cute girl, so the girl is cute now. G with C. And obviously, if that is G and C, so that will be G and C. This one is always the tricky one. If they tell you U here, it's not as tricky when they say U. I'll explain just now as well about that. What happens on this side, if it's U on this side, then we get A on that side, because the equivalent to U in a DNA is thymine. And what combines with thymine? Adenine. So A combines with U. A, U. Remember that. Okay? So A combines with U there in that case there. Remember that this is the messenger RNA. They can then ask you after that, so what DNA strand gave rise to this one? So now you're going right back to the nucleus again. How did this one form? Again, if that's the case, that would be G again. That would be G again, obviously. And here now, because this is DNA, this would be T. So what's this? I don't want to change that to show you something. I don't know why I'm coloring there, but anyway, look at these two. That one and that one. The transfer RNA and the DNA are the same, excepting for the transfer RNA does not have T. So in place of T, you can't put U there. I mean, you can't put A there. That's where the confusion comes. Many people, in this case, they'll put A there. It's not A there, it's U. The A goes here by messenger RNA. Consider the messenger RNA to be in the middle. And the messenger RNA is opposite of the DNA and opposite of the transfer RNA. And that's how we get our answer to a question like this. I'm hoping we understand this, because this one here is easy jam marks. Moving on. A mutation of the first messenger RNA codon occurred, and it read CGU instead of CCU. Katleho? You remember that one? About those mutations and how your name got mutated.
Yes, I remember that.
Remember our first encounter.
Yes.
Right?
Yeah.
Pat and cat.
Pat and cat.
There we
I
go.
remember
All right.
that.
So this is a similar situation. One letter has changed. It read CGU instead of CCU. So one particular nitrogenous base has been replaced by another nitrogenous base. Nothing has been added, and nothing has been deleted. Just one nitrogenous base has been replaced. They want to know, would this be a point or frame shift mutation? Obviously, in this case, it would be a point, because only one nitrogenous base was replaced there. Explain the differences between the two types of mutations mentioned. And we are going to deal with it again in the essay, but let's just deal with it now. Then when I get to the essay, I'll refer you to this as well. So the one is obviously point, and the other one is frame shift. Here, only one nitrogenous base is replaced by another. Okay? That's point. Frame shift, if we add or delete a nitrogenous base. Now the famous one they use there, the dog ate the cat. The dog ate the cat. If we remove this one here, then what happens, remember we must have base triplets. Everything moves. That becomes that, that becomes whatever they add to that there in the end. Now, can we read the second sentence? No. No real words are found in the second sentence. And what has happened? There has been a shift. The whole frame has shifted, left in this case. Okay? The whole frame has shifted left. So this is a frame shift mutation. When one is, in this case, deleted, or let's see what happens if we add. If we had the dog and we add a G there, now it becomes that so in both cases, in this case, obviously you can read the dog up to the dog. After that, unless you switch to Afrikaans, then you're going to say the dog gat. Okay? Or if you want to use your colloquial terms, gat for gun or whatever. But English, if we're using one language, then obviously we cannot complete the sentence. And that becomes complicated for us. And that's where the problem is. In the next question or in the essay, we're going to look at what are the implications of this in nature. The next question, so we've completed that one. And this type of question is linked to what we've just done. So we look at this question as well. The diagram below shows the sequence of nitrogenous base of a strand of DNA. So they're telling you it's DNA, which codes for a part of an insulin protein molecule. AAA, CAA, TAC. They want to know from you, write down the messenger RNA. Insulin, by the way, is a hormone. And one of the characteristics, paper 2 now, guys, of hormones is that most hormones are protein. Insulin is one such hormone that lowers the blood sugar level, just so that we keep that in our head. Don't see this and now start talking about sugar levels and the rest of it, because we are not talking about the functions of insulin here. All they want to know from you here is that if this is the DNA that codes for the insulin, then what is the messenger RNA going to be for this one? If that's AAA, now here, it should have been at TTT, but because it's messenger RNA, that will be UUU. Left to right, you've got to write it in this order. UUU, C would be G, A would be U, U, T now doesn't become U. The opposite of T in this case is A. The opposite of A is U and G. So you write it in this way, UUU, GUU, AUG, AUG, and you get your 3 marks that way. With that, back to you, Katlego.
Thank you. So guys, we are going to go for an ad break. I know I can see all the questions on the page, and I am going to show them to Aslam. I know that some of your questions have already been answered. That's why you haven't received a reply from me. So just stay focused and remember not to move from your seats, because we will be right back.